Okay, so you've been asked to show that p equals y divided by n is a member of the exponential family of distributions. Given that f of y given n and pi is equal to n factorial over y factorial times n minus y factorial times pi to the power of y, 1 minus pi to the power of n minus y. That's what you've been given, and you're trying to show that p is a member of the exponential family of distributions. So you note that y equals np. So I replace all my y's with np. And f of p given n pi is equal to n factorial over np factorial n minus np factorial over pi to the np times 1 minus pi to the n minus np. And I proceed as usual in terms of showing something's a member of the exponential family of distributions. I begin by taking logs of both sides. So log of fp given n pi is log of n factorial minus log of np factorial minus log of n minus np factorial plus np times log of pi plus n minus np times log of 1 minus pi. And then I get the exponential of both sides, so that fp given n pi is equal to the exponential. And I'm going to start by reordering things just so my variable and my parameters are in the right order. np log of pi plus n log 1 minus pi minus np log 1 minus pi plus log of n factorial minus log of np factorial minus log of n minus np factorial. Now I group my like terms together, so I get is equal to the exponential np log of pi minus pi minus log of 1 minus pi plus n log 1 minus pi plus log of n factorial minus log of np factorial minus log of n minus np factorial. And I express this in its more natural form, which is np times log of pi divided by 1 minus pi plus n log 1 minus pi plus log of n factorial minus log of np factorial minus log of n minus np factorial. Okay, at this point you have to use a little trick, which is to recognize that you do not want this n hanging around here, and the easiest way to do that is to divide above and below the line by n. So np divided by n times log of pi into 1 divided by 1 minus pi plus n over n log 1 minus pi all divided by 1 over n. So it's exactly the same thing, plus log of n factorial minus log of np factorial minus log of n minus np factorial. Tidying it up a bit, you get rid of those. So I get exponential p into log of pi divided by 1 minus pi plus log of 1 minus pi all over 1 divided by n plus log of n factorial minus log of np factorial minus log of n minus np factorial. Okay, now I let phi is equal to n. This is mainly for convenience. A of phi is equal to 1 over phi is equal to 1 over n. Let theta is equal to log of pi divided by 1 minus pi, so that e of theta is equal to pi 1 minus pi. And with a little bit of algebra, you can show quite easily that pi is equal to e to the theta divided by 1 plus e to the theta, and 1 minus pi is equal to 1 over 1 plus e to the theta. So log of 1 minus pi is equal to log of 1 over 1 plus e to the theta, which is equal to minus, because this is all 1 plus e to the theta to the power of minus 1, log of 1 plus e to the theta. So now we can write this term here in terms of p, theta, and phi. So f of p given phi and theta is equal to the exponential of theta p, that bit, minus log of 1 plus e to the theta, this bit here, divided by 1 over phi, plus log of phi factorial minus log of phi p factorial minus log of phi minus phi p factorial. Now, for something to be a member of the exponential family of distributions, it needs to be in the form exponential of theta x minus b of theta over a of phi plus c of theta of phi even x. Here the equivalent of my x is p, and then I can match everything else up as I would like. So I get f of p given phi theta is equal to the exponential of theta p minus b of theta over a of phi plus c of phi given and p. This is just a function of phi and p, that's all fine. So at that point I can say given b of theta is equal to, and I match it up, log 1 plus e to the theta, a of phi is equal to 1 over phi, 1 over n. You can show that that's a member of the exponential family of distributions. And c of phi p is log of phi factorial minus log of phi p factorial minus log of phi minus phi p factorial. At that point, I've shown as a member of the exponential family of distributions. I can extend this working to look at the expected value of p, which is going to be the first derivative of b of theta with respect to theta. So that's a d theta of log of 1 plus e to theta, which is equal to the derivative of what's inside the log, 1 plus e to theta, which is equal to pi from back up here. And then the variance of my proportion is equal to a of phi d squared d theta squared of b theta, which is equal to a of phi, which is 1 over n, times d theta of e of theta 1 plus e to the theta, which is equal to 1 over n times e to theta over 1 plus e to the theta, to be squared by application of the quotient rule. And then I note that, or even recall, e to the theta 1 plus e to the theta is equal to pi, and 1 over 1 plus e to the theta is equal to 1 minus pi. So e to the theta 1 plus e to the theta squared is equal to pi times 1 minus pi. So the variance of the proportion is equal to pi times 1 minus pi divided by n, as required, and as you should know from other types of statistical analysis.